before I start setting up on the mill, I'm just going to fit a temporary ball race into the drive side, so I've got a reference surface to work from. I'll do this in my usual manner. I'll be back in a moment when I've got the mill walked into this case. I've got the bearing in the freezer in the usual manner again, and it's mounted on a bearing mantle. Back in a moment. Just like that. I'll let that cool down a bit, and then we'll take it over to the mill. I've got the bearing, temporary bearing, in the drive side case, a ball race. That's to allow me for getting a centralising off that when we set up in the mill. I've got the studs back in and cleaned up, ready to go. I've got a selection of bearings. I've got various options with that, and I'll discuss some of it as we go along. But we've got our normal NKIB type of roller, our needle roller combined ball thrust there, that's normally fitted to these conversions. I've also got just the needle roller part of that as well, called an NA4906. That's the other option, but we've got to do pull the crank up to one side or the other. In this case it goes up to the timing side. On the earlier A7s it was pulled up to the drive side. If we pull it up to the drive side, I've got a bearing there called an NUP206E. That's got a separable inner race. Let's show you that quick. So we've got the normal roller bearing, but we've got a separate ring there to allow that to control the axial movement of the crank. So that will, the idea of that will be put that in the drive side and that in the timing side, and then we've got control that way. And that's the normal sort of A10, A7 type roller bearing there, where we've got that on the crank and that in the case. There's another version of this bearing where the inner race can go on the crank and the bearing can go in the case. So kind of that and that go together, and that go together. And I think I'm going to change this up a bit. I think I'm going to do it a little bit different, just because we can, really, just to try something else. As I go along with fitting this one, I'll talk about fitting that one, because there isn't much difference. It's just how deep you bore the case and a few other details with the timing gear and things like that. So we'll discuss that. It's been mentioned, why don't I just do the bush? Well, I've done countless bushes over the years. I could do the bush, but that's not the object of the exercise. We try and do something a little bit different, and I want to try this this conversion to a roller bearing instead of the bush. when we've got the cases on the mill, we'll centralise, say, off the drive side and then go down to the timing side. Again, the question comes up of, aren't you supposed to line bore, line ream, use the BSA tool, etc. There are many options, not all of them the right way, not all of them the wrong way, but let's get them together for a second. So I'll be setting, move that out of the way, I'll be setting this up in the mill and aligning it from the drive side through to the timing side and boring that side hole. If I was just doing a bush, I'd do the same setup, making sure that we're in alignment. So that'd be, call it line boring, aligned boring, boring in line, however you want to do it. The question about the reamer, right, the BSA plate that went on there with the reamer that went through, as far as I can ascertain, was for the very early cases with the white metal bush, where that had ream okay. After the white metal bush came that type of bush with the insert inside, some pinned and some not. That's actually a pinned one, and I don't think this has been out of these cases, so that's original, and they're not designed to be reamed. They're pre-sized, put it in, put it together, quick assembly. You've got to remember, it's got to be fast on a production line. You can't mess around reaming everything. So it'll be worked out what size it needs to be, allow for the crush on the fit of the bearing and everything, and go together. So the bike shops of the time would have been replacing with that type of bush. The modern bushes, a lot of them are the solid bronze ones. Not always to size. And then, yeah, you need to, most of the time, bore them out to size to suit the crank. Say you can do it on the mill, or if you want to ream, if that's your only option. Give me a second. Most people are talking about that type of reamer, which is far from ideal. It's alright sort of for tractor kingpins and things, and with care, yeah, you can get away with it. But you want an extension like so. So that will screw on to our reamer. That is then able to pass through our bush, which is actually on the other side, through the bush into the bearing on the drive side, and then you've got alignment for reaming. That's what most people consider line reaming. And while we're set up like that, with a drive side bearing temporarily in bore race, yeah, we can get it back in line with things. I say the problem is getting finish and getting to tolerance. You've got to be extremely careful and very clever with one of these to achieve that. So yeah, I've got that option, but I choose not to use it. So that'll go in, passing the reamer right the way through there, if we want to line ream a bush, not this bore. So I'll get this set up on the mill table now, and I'll go through what we need to do for that. Just as a first stage to set it up on the mill table, I run a fine file just over the joint face there, just to get rid of any high spots. that might exist. And we also obviously we tram the mill in very carefully, make sure the head's in alignment, etc. before we start the job. We're roughly bolted down to the table in such a position that I can get a dial test indicator to sort of 4 points on the joint faces, front, back, left and right, to check that we're horizontal with the table. So with the reading taken from one position, I can then unlock the table, because everything and the quill, everything needs to be locked up, the knee and everything for all the setup. And then take a reading, retract the quill, having already set a 0 on the digital readout up here, move the table across, back down to 0 on the DRO up the top there. If I just pan up a little bit, so we're on that scale up there, we're on 0 on there, and then we can come back down, move everything across, and we want to be coming back to 0 on the clock. And this time moved across where 0.14 over a 0 point at, where's it gone? There it is, at 0 on the DRO again. So I just need to do a little bit of shimming on the cases, just lift the side nearest to me a little bit, and until I can even them two readings out. Right, I'll see if I can get this on video. This is quite a bit of time later. It takes some faffing about with this. So I'll 0 my DRO, 0 my DTI. I'll take that up. I mean, what I could do with here is a decent length parallel to go across the cases and some shims onto the joint faces, so I can just run it straight across. Well, I haven't got one that reaches, that's flat enough, something I'll have to work on. So I'll come across to the other side and I go back down to my 0 on the DTR, on the quill indicator. Just knock that through there, and we're on 0 there. We can see that, and on my quill depth I'm on 0 as well. So that's pretty good in that direction. So now I'll repeat the same thing for the, let's come out a bit, I'll repeat the same thing across sort of from this point to sort of this point somewhere across here. Exactly the same thing, make sure we're level that way. There we are, cutting up bits of shim steel to suit the occasion. Just takes time, you've just got to be careful with it. And at that point on the case, again, after a little bit more playing about, we're at just negative by 0.06 millimeters. It's about 3 thou, and we're still on 0 on our quill DRO. So still at 0 on the quill DRO, we've moved across again and we're onto that little post there where the hidden stud is, and we're on just a little past 0 there. So that's pretty damn close. Yeah, it's actually worked out better than I was expecting, to be honest. They're pretty flat cases, they are. Normally like bananas. When you try and do this, it sends you mad. So now at this point I'll unlock everything, drop everything down, and we'll put the drive side case on. In fact, no, I'll tell you what I'll do. I'm just going to roughly centre on that, just get roughly above it to start with, and then we'll pop the drive side case on. And just worthy of note, there's a 3 thou shim just under there to correct everything. Well, I'm quite pleased with how that worked out, to be honest. It doesn't normally work that way. They normally end up like bananas. If the joint surfaces aren't flat, you're fighting a terrible battle. But with that set up now, remember we're right out here at the extremities. What we're trying to get, because this surface is level, is we're trying to get that bore in there vertical, and with only sort of, what I say, 0.06 there, by the time you've got down to that point it's negligible. So yeah, I'm happy with that. I'll just about get this before the battery's flat. That's set up now with a coaxial indicator or Blake indicator, finding the centre of that bore down there. And I've got a good feel about this one. That is set. That is just roughly it, and it's barely flicking at all. That's less than 0.01. Now there is a factor to take into account with the length of the probe on these, but that gets us in the ballpark. What happens with this, I'll just set the DRO to 0. Give me 1 second. What happens with these, for those that aren't familiar, as I move an axis, that needle deflection, here I'm moving, I move across there, there's the table moved a little bit, and that deflection grows the further you are from concentric, and then as I bring the table back into position, we get to that point. I'm just looking what the digital readout's doing as well, so apologies if I drift. That's not bad. I'll re-zero again at that, and you just do it a couple of times. So that's changed by 0.035 millimeters. So now we're at that point with that bore, and it also shows the bore's pretty flipping circular. It's not bad at all, that isn't. Again, they're normally like eggs, or in a lot of cases they're like eggs. Very oval, that's pretty circular. So yeah, that's good cases actually, surprisingly, despite the blow up. Try and get this part. I can't remember where I was up to. The case half, the top half's back on with a few bolts and studs in it. The case breaker nuts on there, quarter stud there bolted through. I've got some studs at the back, so everything's bolted down. I've just done a quick sweep, and surprisingly quite good. Try and stay in shot. Bring you in a little bit. Oh, not in focus. Just leave it at that. You roughly see the needle. So that's sort of to the right. Again, we'll do our 4 points. We spin round, come back round there, and that's sort of my plus 20 there. which is 0.2 millimeters, about 7th thou, and we go round to the opposite side roughly, and we're about -20 there, minus 0.2 there. So all I'll do there is move the table across till we get to a 0 point. Front to back, again, is surprisingly quite good. We can just see that way. I'll try and get in. Apologies for the dodgy chrome. We're just, what are we, just past the 0 at that point. 0.03, something like that. And round here, oh, and I've just hit the bloody gauge, haven't I? That's cocked everything up. Yeah, I'll come back to that. We were 0.03 there. We're about right front to back, but we just needed to adjust left to right a little bit. I'll get it set up and then I'll show you it properly. It's very awkward trying to do it with the camera as well. I'll attempt to get this on camera in one shot. So there we are, around about 0, and as we sweep round, it's disappearing out of shot there. Get back in it. Ooh. As we sweep round, if we can see that in the glare, we're still on 0. Come round a bit more, another quarter, we're still on 0 there, just slightly before, and back round to the beginning, we're still on 0, and without moving anything, just so we know that it's not some kind of magic trick, I'll take the quill up, and there we go, we're off. So you know we're in contact with the bearing. So that just took a little bit of fiddling about. We know we're absolutely concentric with this one. Now take the case off again, and we'll recheck down below again. And if there is a difference, what we'll do is average it out between the two. The likelihood of it being absolutely spot on the same is quite slim. So you average your difference. Remember, you're sort of 6 inches or so away from the other one. By the time you get closer to the table, away from the table, yeah, there's little bits of movement. You'll never get it, or you're highly unlikely to get it absolutely perfect. You've got to allow a little bit of tolerance, but you're within the ballpark. That's where we are so far. I think I'm going to call it a wrap at that for tonight, and go in, probably do some editing, and maybe even try and get this one published tonight. So we'll see. What date are we on today? Is it Wednesday or Thursday? I've lost track of the days. I think we're Thursday, aren't we? So we'll see how we go. And one last one, you know that we're horizontal, you obviously know we're vertical, and we've checked that on the barrel face and on the sump plate face as well.